In this problem, we're going to find the current I0 using source transformations. And let's review quickly source transformations if we think about it. The source transformation allows us to transform between a Norton equivalent circuit and a Thevenin equivalent circuit. So if we look at the two circuits, then we can transform between these two. And remember, of course, R Thevenin is V open circuit over I short circuit. So this is a source transformation. We can transform a current source in parallel with a resistance into a voltage source in series with a resistance, or we can take a voltage source in series with a resistance and combine it in parallel, or combine it to form a current source in parallel with a resistance. And we want to take note of our current I0, okay, because we don't want to combine it in any transformations. Now if we look, to start off, we have two parts of the circuit that we can transform. So let's perform the source transformation on those. We do our circuit will now become the following. So the 12 volt and the 6K are the same. Here's a 2 kilo ohm resistor. Here's that current I0. Now this was a current source in parallel with a resistance. Now it's a 1 kilo ohm resistor in series with a 4 volt source. This was an 8 milliamp source in parallel with a 3 kilo ohm resistance. Now it's a 3 kilo ohm resistance in series with a 24 volt source. If we look, for instance, these two can be combined in series to give us a 9K. And now we can do a couple more source transformations. Let's do a source transformation on that part, and let's do a source transformation on that part. So now I'm going to take those and combine them, or convert them to current sources in parallel with resistances. So if we do that, so we didn't do anything to this part of the circuit. Again, we're not going to involve the 2 kilo ohm resistance. Now, this combination here, series combination, here's the 6 kilo ohm resistor. This is a 2 milliamp source. Here's the 9 kilo ohm resistor. And now this is 8/3 of a milliamp. Now, if we look at that circuit, remember we can combine current sources in parallel and resistors in parallel. So for instance, we can take these two current sources and combine them in parallel, and these two resistors and combine them in parallel. If we do that, our circuit can be reduced to the following. Okay, so that a 9K resistor in parallel with a 6K resistor becomes 3.6 kilo ohms, and then this current source now has a value of 14/3 milliamps. So now let's combine or convert that from a current source in parallel resistance to a voltage source in series. and the circuit becomes this. So this becomes 16.8 volts, so 14/3 milliamps. Current source and parallel resistance becomes a 16.8 volt source, and here's a 3.6K resistor, and this is a single loop circuit, and we can calculate I0 is minus 16.8 minus 4 over 3.6K plus 2K plus 1K, so that's minus 1.94 milliamps.